Hi students, welcome to this video. In this video, we are going to discuss about 8th standard physics, chapter 3, force and pressure. So today we are going to only concentrate on force. So first we are going to discuss about what is force. So students, so already we know about how force is produced. So force means what? A strength. Okay, how much we have strength, we are applying, we are converting into force. So here we are going to discuss about what is force. So students, when we want to open a door or when we want to close the door, what we have to do? So many times we are going outside or we are going to any kind of shops. They are placed on sticker on the door, main door. So what they are written there? So we can able to see push or a pull. Okay, so if they are in push means what you have to do? We have to push the door moves away from us. Okay, so like that, when we push the door with our hand, the door immediately open. You can see this the gif image. So this is the door. Now the door is pushed, the door moves away from us. So next, if you want to close the door means what you have to do? Yes, we have to pull the door, the handle with our hand. So when we pull the door will be closed. So sometimes some relatives they are coming to our home means what you have to do? So first we have to open the door, then next we close the door. Okay. So this means that to move an object, it has either to be pushed or pulled. So not only the door, if you want to move a bench from that place, so what you have to do? Whether we have to push or a pull. So from this we are clear about what is force. So force is nothing but a push or a pull on an object is called force. Very good. Okay student. Next we are going to see about direction of force. So what is called the direction of force? So it is very easy. The direction in which the object is pushed or pulled is called the direction of force. You can see that the first picture, the person he pushed the table. So if the person is pushed the table, what will happen? The object move from to right to left side. So from this we can easily understand the person on which direction he push the object will move in the same direction. You can see that the second picture, the person pull the table. Okay, if the person is pull the table means the object moves towards this person. So from these images we can clearly know the direction of force. So direction in which the object is pushed or pulled is called the direction of force. So now again we can recall the door example. So students, we open or close a door by applying force. Already I told you before that. So student, when we push the door to open it, then we apply a force on the door in a direction away from us. I already told you, no. So when we push the door with our hand, so the force is applied on the door. So when the force is applied on the door, the direction is away from us. So same like that, when we pull the door to close it, then we exert a force on the door in a direction towards us. So already I told you. So when we pull the door will close. When the door is closed, it moves towards us. So from this also we can easily understand the direction of force. So you can see that the GIF image also shows like that. So when we push the door in the direction away from us. When we pull the door in a direction towards us. Okay, student. Next, we should know the meaning of interaction. So in English, interaction means so communicate each other. So in physics, the interaction means it's a reciprocal action. We have to keep it in your mind. Interaction means reciprocal action. So this means that involves two objects. Interaction means involves two objects. Must interact two objects. In interaction, each object acts in such a way as to have an effect on other object. You can see that the picture, the two sides are three peoples are there. They are pulling each other. So one side of they are pulling the rope, and another side also they are pulling the rope. So here the two objects are involving. They are giving the equal and opposite force. Okay, so from this we can easily clear the interaction means to act on each other. The force act on each other. Interaction means the force act on each other. So you can see that the picture, the man pulling the cow is also pulling the man. So here also there is an interaction between two objects. That's mean to act on each other. So next we are going to discuss about force is due to an interaction. An interaction of one object with another object result in a force between two objects. So from this we can easily clear interaction means what? Reciprocal action. So if you want to interact with the object means there should be two objects must interact with each other. You can see that the picture, the man pushing the ball, okay, the kicking the ball move from a way, move from another side. Okay, so here the two objects are involving each other, then only the result is a force between two objects. So simply in other words, a force arises due to the interaction between two objects. So from this we can clearly know at least two objects must interact with each other for a force to come into play. So students, so from this we can easily understand if a force can occur means there should be two objects must interact with each other. So next, one more example we are going to discuss. So here a man is standing behind a stationary car. You can see that the picture, a man standing behind a stationary car. So in this picture there is no interaction between man and the car. So you can imagine, is there any force is act on the car? No, there is no force act on that because there is no interaction between man and the car. So the man pushes the car. So is the car is moving now? No, the car does not move from the place. You can see that the next point, when the man pushes the car, there is an interaction between the man and the car. You can see the second picture. The man started to push the car. So what will be happen? Definitely a car move from the place because a force arises which acts on the car and makes it move in the direction of applied force because the man pushing the car. So there is an interaction. Already we know that interaction means at least two objects must interact with each other, then only the force come into play. So here the force is come into play, the car is started to move from the place. So if the both objects are capable to applying force on each other, then the interaction between them can be pushing or pulling. So what kind of interaction we are giving, the resultant is the forces come into play. So next one example we are going to see about the two girls are interacting and applying force on each other. You can see that the picture, the two girls are interacting and applying force each other by pushing each other. Okay, so here also the force come into play because there is two objects are there. They are what kind of force they are applying? They are push. Okay, they are pushing each other. So students, next we are going to discuss about moment of force. So it is some a difference between what is force and the moment of force because something is different from that force. Okay, so you can listen carefully. The moment of a force is a measure of its tendency to cause a body to rotate about a specific axis. So before that we discussed about what is force. What is force? A push or a pull on an object is called force. There should be a push or a pull is applied on that object. But here we are going to see about the body to rotate. The force is applied to the body to rotate about a fixed axis. It is also called as torque. In physics, it is also called as torque. You can see that the GIF image. So this is the nut. Okay, this is the nut. This is the spanner. With the help of the spanner, so we are going to rotate this. So that is nuts is started to rotate about a specific axis. So if you want to rotate this nut with the help of the spanner, we have to apply a force. So this is called a torque effect. So this is different from the tendency of a body to move or translate in the direction of a force. So students, for our better understanding, let us take the example of opening or closing a door. You can see the picture. Again, we are going to taking a example for a door. Okay, so from this you can clearly understand. So already we know that a door is a rigid body because a door is fixed in a place, okay, with the help of the hinges. Already we know that the hinges, you can also see in your home also, the door always fixed with the help of the hinges. So this is the hinges. I'm showing you, this is the hinges. Okay, the hinges, the door is fixed with the hinges in a vertical axis, okay, because it should be in vertical position. Okay, door is always in the vertical position. So what makes the door rotate? Already we know that. There is a handle they are given in the door. If you want, or if you open or close the door, we have to push the with the help of the handle, we have to push or pull the door. Then only the force is come into play. Then the door is rotated. So without force, is it possible to rotate the door? No, it is not possible to rotate the door. It is clear that unless a force is applied the door does not rotate. So and also, but any force does not do the job. Okay, student, I think you clear the with the help of the example. Again, I'm going to clear one more time. A force is applied. Now the force is applied to the hinge line, cannot be produce any rotation at all. So sometimes if you not push the door, without pushing the door, if you push the hinge, means is it possible to rotate the door? No, we cannot. If you are applying the force on the hinges also, the door does not move from that place, because so the force is applied on that hinges only. So here, whereas a force of given magnitude applied at the right angles to the door at this outer edge is most effective in producing rotation. So if you are applying more forces in the on the hinges, the door does not move. So if you are applying a force on the door in the right angles position, the door definitely move from that place. A movement is due to a force not having an equal and opposite force directly along its line of action. So you can see that the second picture, from this picture you can easily clear. Okay, you can see this is the F2. In the F2 position, if you are applying a force, means is it possible to rotate the door? No, it is not possible to rotate the door. So you can see this is the F1. Is this if you are applying a force in the F1 position, is it possible to close the door? No, it is not possible to close the door. So you can see this is the F3. So F3 position only, if you apply the force, then only the door will close or open the door. So you can see that the picture, F1 and F2 will not produce rotation because it is not in the right angles. Right angles means 90 degree. Okay, so another very common example that you might have seen at your homes is wrench. Okay, wrench means what? Spanner. Okay, simple word is spanner. Wrench means spanner. You can see this. A wrench is a tool used to open or close the nuts. It works on the same principle of moment of force. Okay, very good. You can see this picture. This is the wrench. So wrench rotate the nut. The nut is in the pivot position. Okay, pivot position. So pivot means what? It is a specific rotation. Okay, it is in the specific rotation. So the span is always rotates in right angles. Okay, so the force should be given in the line of force. Okay, it should be, the force should be given in the line of force. Then only it is easy to rotate. The force is applied perpendicularly to its one edge, whereas another edge is held in the nut. So this is also, I already told you, the center of nut acts as a pivot. Pivot means center point. Okay, it does not move. This is a rigid support. The perpendicular force creates a movement or turning effect, and this helps to fasten the nut. Okay, so when we rotate this wrench, then only the nut is to fasten to tighten. Okay. So next, the force will cause a turning effect only if the line of action of force acts perpendicular or has some component perpendicular to the pivot. I already told you, if you want to rotate this nut, the wrench should be in the position of perpendicular direction, not in the straight direction. It should be in the perpendicular direction. The force should be given in the line of action. Then only the wrench will rotate. When the wrench is rotate, it started to tighten the nut. So whenever we are applying force on the wrench, the force should be in the right angles to the wrench. So next we are going to discuss about elements of a moment. Elements of a moment. Yes, the magnitude of the moment of a force acting about a point or axis is directly proportional to the distance of the force from the point or axis. So you can see this picture. So this is the object. So we are pulling out the iron nail. So with the help of the hammer, the hammer is with the help of the hammer we are removing the iron nail. The force is given on the right angles. The distance, okay. So when we are giving the force on that object, the distance and the force is very important. So the distance is force is very important. From this only we can able to form the formula for torque. So torque is defined as the product of force and the momentum. Product of force and momentum is also known as distance. So distance is also known as momentum. Okay, so the momentum or lever arm is the perpendicular distance between the line of action of force and the center of movements. Okay, you can see the next picture. So this is the nut, this is the pivot point. So the wrench is connected with the nut. The force is applied on that edges of the perpendicular direction of the edges of the wrench. Then the distance between the lever arm and the force applied is combined, is multiplied with the torque. So the torque is equal to, yes, what? Torque is equal to force into distance. That means momentum. So next one, that only we are going to discuss. So students, in case of a large students, in case of a longer is the moment arm, larger will be the torque. If the moment arm is larger, the torque will also larger and also stronger is the force. Larger will torque. Okay, so from this we can easily form the formula. Moment of a force is equal to force into momentum. That's mean F into D. Okay, this picture also will explain more. So this is the pivot point, this is the distance we are applying force here. So the formula is the moment of force is equal to force into momentum. Okay, next we are going to discuss about units of moment of force. Okay, so we should know the, already we know about the SI unit of force. So what is the SI unit of force? SI unit of force is Newton. Very good. What is the SI unit of distance? SI unit of distance is meter. So from this we can easily form the unit of torque. Okay, so the SI unit of moment of force is Newton meter. N capital N, a small m. A moment is also expressed in units of foot pounds or kilonewton meters. So we can write like this also. So if they are asking SI unit of moment of force, we have to write Newton meter. So students, 1 Newton meter is equal to the torque resulting from a force of 1 Newton applied perpendicular to the end of the movement arm, that is 1 meter long. You can see that the picture. So this is the wrench. The length of the wrench is 1 meter. So we are going to applying a force 1 Newton. So if you are applying 1 Newton of force in the wrench of 1 meter, means the torque will be 1 Newton meter. Okay, students. So next we are going to positive movement and negative movement. What is the positive movement and what is the negative movement? So we are going to clear with the help of the examples. So a movement also has a sense. A rotation about the center of movement will be considered a positive movement, while a counter clockwise rotation about the center of movement will be considered negative. You can see that the picture, the two person, one side of the their boy is standing there, one side of the girl is standing there. This is the seesaw. Okay, seesaw. Okay, the distance between two objects is the same. This is the 2 meter. The girl is also 2 meter and boy is also 2 meter. But the weight, that's mean the force given by the boy is 300 Newton, but the girl's weight is, they are given force is 600 Newton. So with the help of the formula, we have to apply these values. Then only we can easily able to we can calculate the clockwise movement or anti-clockwise movement. So in the girl side, it rotates in the clockwise direction because the weight is the force is very high. The force in the 600 into 2 meter means 1200 Newton meter. Moment of force is applied. So if the moment of force is very high, it is in the anti-clockwise rotation. So here you can see this 300 to here 2 meter. So 3 into 2 600 Newton meter. So here the rotation in the clockwise rotation. Here is the movement is in clockwise rotation. Okay, student. Next, we are going to see some numerical problems. So you can see the first numerical problem. A force of 100 Newton is applied perpendicularly on a spanner at a distance of 10 centimeter from a nut. Find the torque produced by the force. So first we have to write the solution. So already we know that before substituting the values, we have to see in the values in the expression of torque. Here they are given in centimeter. We have to convert it into meter because the SI unit is Newton meter. We have to convert it into meter. So already we know that if you want to centimeter to meter, 1 meter is equal to 100 centimeter. So first I am going to convert distance is equal to 10 centimeter is equal to 0.10 meter. So next torque formula. What is the torque formula? Torque is equal to D into F. So I am going to apply this value in that formula 0.10 into 100. So we are getting 10 Newton meter. So finally we can get the torque produced by the force on the nut is 10 Newton meter. So second numerical problem. The steering of a car has radius 16 centimeter. Find the torque produced by a couple of 15 Newton. You can see this. This is the steering. This is the center point. This is pivot point. They're given here radius is 16 centimeter. That's mean distance. Okay, distance. Radius means here we are going to taking as a distance. So solution we have to write. So see figure, pivot is the center steering of the force is applied along the ring. Hence in the case. Okay, distance is equal to radius. Already I told you. So here also they are given in centimeter. We have to convert it into meter. 16 centimeter is equal to 0.16 meter. So next we are going to write the formula. Torque is equal to D into F. That means force into distance. So we are going to apply these values into the formula 0.16 into 50. So finally we can get the torque is equal to 8 Newton meter. Okay children, thank you for your listening. Thank you.